Good morning, good afternoon, and good evening, everyone. Okay, thank you, Dr. Murthy, for the warm introduction. Okay. So we'll talk about observability and AIOPs in this session today. And many of you may have participated in a lot of talks yesterday about ChatGPT. So I'm not covering about ChatGPT in this session, but I expect that ChatGPT will have a role to play in AIOPs in the months to come. Just like how it has a potential to impact many verticals. So here's a little bit about myself. Again, I'm not going to talk about it much as Dr. Murthy has already provided the introduction earlier. Here's the agenda for today. We'll briefly talk about the problem we're going to discuss today, define observability, challenges with current observability tools and practices, define AIOPs, and how AIOPs can help address some of these challenges. Finally, we will discuss a case study of a large company which successfully implemented AIOPs on top of observability data. Before we jump into observability and AIOPs, let's look at some findings from a recent report on IT outages and impacts. The study found that unplanned outages cost businesses on average $12,900 per minute. The impact is even significantly higher, almost double for companies over 20,000 employees. And significant recent outages cost companies on an average of almost $1.4 million. The costs are staggering and high as companies see these outages frequently with the long times to restore service. Now, let us try to dig in and see how observability and AIOPs can help address some of these challenges. Many of you may be familiar about observability, but I'll give a brief introduction in case you're not, and then dig into the AI aspects of it. So what is observability? Observability is a concept that refers to the ability to infer the internal state and behavior of a system based on its external outputs without having to access its internal workings directly. Like in other words, it is the ability to observe and understand the behavior of a complex system without having to fully understand its internal structure or workings. Observability is sometimes used synonymously with monitoring, but it goes beyond simply collecting data and instead focuses on making the data accessible, understandable, and actionable. For instance, a check engine light on a car is similar to monitoring. It tells you something is wrong, but does not provide additional insights. When you take that car to a mechanic, he can run additional diagnostics to find the root cause. Observability provides us with such powerful capabilities to probe further on demand to troubleshoot and resolve issues quickly. Observability involves collecting and analyzing data from various sources, including logs, metrics, traces, and other telemetry data to gain insights into the performance and behavior of a system. Logs, metrics, and traces together have traditionally been defined as three pillars of observability. Though the three pillars definition is slowly fading away with some of the more modern observability techniques we're seeing and with more modern observability vendors that are coming up with new techniques. Metrics typically answers the question, do we have a problem? By highlighting anomalous behavior in metrics such as red metrics, such as rate, error, and duration. Logging typically answers the question, what is causing it? By providing fine-grained detail on a given service. And distributed tracing typically answers the question, where exactly is my problem? By helping us narrow down the search space further along with metrics and logs. Observability tools are used to resolve hundreds of incidents every day. However, there are still shortcomings in these tools, resulting in the problems we discussed earlier, especially the ones related to long and expensive outages. Now let's explore some of these challenges. First, the modern systems are highly complex and often involve a mix of on-prem and cloud-based infrastructure, as well as wide range of applications and services. The complexity can make it difficult to gain a comprehensive view of the system performance and behavior, and to identify the root cause of issues when they occur. These systems generate a vast amount of data, including logs, metrics, traces, and events, normally called as MELT, metrics, events, logs, and traces. Managing and processing this data can be challenging, especially when it is spread across multiple systems and tools. Next, observability often involves using a range of tools and technologies, including logging platforms, monitoring solutions, and tracing systems. This can lead to a tool sprawl, making it difficult to manage and analyze data from various sources and to get a unified view of system performance. And all these solutions can generate many alerts, which can quickly become overwhelming for SREs and developers. This can lead to alert fatigue, where important alerts are ignored or missed. Next, implementing observability requires a range of much sought after technical skills, including expertise in data analysis, machine learning, and cloud computing. And finally, the cost of implementing and maintaining observability tools can be a significant challenge for organizations. The costs can be related to licensing and subscription, infrastructure, integration, training and support, inefficient tool usage, etc. While the traditional observability tools continue to solve some of the above issues, the complexity and scale warrants intelligent solutions that are built on top of them. And that's where AIOPs can help. So now let's see what is AIOPs. AIOPs, or Artificial Intelligence for IT Operations, is a technology approach that leverages AI and ML to automate and enhance operations. AIOPs aims to improve the visibility and speed of operations by using advanced analytics, data processing, and ML algorithms to identify patterns, anomalies, and correlations in data generated by IT systems. It brings together multiple data sources such as logs, metrics, events, and traces, and applies ML algorithms to identify patterns, predict anomalies, and perform root cause analysis. This approach helps SREs and developers to proactively identify and resolve issues before they become critical, and to reduce the mean time to resolve, MTTR. AIOps is normally built on top of observability data along with a few other sources of information such as incidents, service maps, etc. So let's look at how this is done. As mentioned in the earlier slide, AIOps is implemented on top of observability data by leveraging ML algorithms and other AI techniques to analyze and correlate data from different sources. The aim is to detect anomalies, identify patterns, and predict potential issues before they occur. Here is a general overview of how AIOps can be implemented on top of observability data. First, collection of data. The observability data is collected from various sources, like we talked about the 3 pillars earlier, right? Such as logs, metrics, traces, and typically is consolidated into a central repository. This data provides a comprehensive view of the system's performance, health, and behavior. Next, processing of this data. The data is then processed to extract meaningful insights, such as identifying patterns and trends, detecting anomalies, and identifying correlations between different data sources. And third, applying machine learning on this data. So ML algorithms are then applied to the data again to identify patterns and anomalies that would be difficult or impossible to detect manually. The techniques could include supervised learning, unsupervised learning, and deep learning algorithms. The fourth stage is to generate insights after we applied the machine learning algorithms. The results of the ML algorithms are then used to generate actionable insights, such as alerts, recommendations, creating incidents, and automated actions. And finally, the AIOps platforms continually learn from new data and feedback, enabling them to improve their accuracy and provide increasingly valuable insights over time. So today, many observability vendors and also the AIOps vendors offer a variety of solutions in this space. A lot of the observability vendors today offer full stack observability in the sense they actually they provide solutions for metrics, logs, traces, visualization, but they're also offering solutions for AIOps. And then there are just AIOps vendors who are able to work with a variety of data streams that you already might have, especially in a large company, large deployments, you might already have the data. So AIOps vendors can consume the data streams that you already have and provide intelligence on top of it. Overall, AIOps provides a way to automate and augment the analysis of observability data, enabling SRE teams and developers to identify and resolve issues quickly and proactively. By leveraging artificial intelligence and machine learning, these platforms can provide faster and more accurate insights into the health and performance of the systems, reducing the impact of outages and improving the overall reliability of cloud services and applications. Just going back to the problem that we discussed early on how impactful these outages are for these large companies. Now let's see an example of a large enterprise that has implemented AIOPs successfully. Verizon successfully implemented AIOPs platform to monitor and manage the network infrastructure, which spans more than 2.5 million miles of fiber. They leveraged machine learning algorithms to analyze data from various sources, including logs, metrics, and traces, to identify potential issues and predict network outages before they occur. They also leveraged natural language processing, the NLP techniques, to understand and categorize issues, enabling faster resolution times. Overall, they were able to reduce the mean time to repair or mean time to resolve almost up to 50%, and alert noise by up to 90%, leading to significantly improved reliability and performance of the network infrastructure. And they're considered to be one of the leaders who have successfully implemented AIOPs platform. There are a lot of other customers who have done this. You can also look at Netflix's Atlas platform. It's a telemetry platform. Again, it has been created much before some of this AIOPs became a very big thing. A lot of it has been implemented by themselves. So you can take a look at the Atlas platform, which is widely used by Netflix to actually ensure highly reliable video streaming service. And there are many more examples. But today, as I mentioned, a lot of companies are able to use the AIOPs provided by the vendors directly, observability vendors directly, especially if you have your logs, metrics, and traces with them. And that's an easy solution where they're able to take all the data and correlate it for you and provide intelligence on top of it. But if the data comes from disparate sources, then it's always a challenge, right? They can provide minimal capability, but there's things are evolving in this space also where they can query other disparate sources and also provide intelligence and correlating across all the pillars of observability. Again, to summarize, in conclusion, observability and AIOPs are crucial for managing and optimizing complex cloud services and applications. Together, they provide powerful tools and techniques for detecting and diagnosing issues, optimizing performance, and improving the efficiency, reliability, and resiliency of cloud services and applications. If you go back and look at the problem we talked about, how these outages impact so many of the customers each and every day. Definitely, observability and AIOPs are crucial for managing such outages, reduce MTTR, reduce the impact, and overall improve the efficiency, reliability, and resiliency of all these services. So that's all I have to presentation today. I definitely appreciate the opportunity given to me today by Global Big Data Conference. Sridhar, Dr. Murthy, Leena, everybody. Thank you very much for the opportunity. I'm happy to take any